Okay, beginning our introduction into calculus, and very exciting to make that jump. We're starting off with one of the basics of calculus, and that is learning about a limit. And you're always going to see limits abbreviated by LIM. You can see that all over this page. But a limit, you might think, well, what exactly is it? It always refers to a y value. Whenever you see a limit at the end of the problem, what they're really saying is, what y value are you getting close to? What y value are you getting close to? Notice I didn't say what y value do you equal, or does the function equal? Very different question. Instead, we're saying what y value do we get close to as x gets close to a certain value. So tell you what, I want us to just take a look at this first problem on the page here, number 4. And I'll scoot down. We're always going to have a picture. And can't tell you enough that sometimes you're going to see a minus and a plus associated as well. Ironically, I'd like to begin with 4b, talking about that negative right there. And sometimes kids look at that and will say, what does that really mean? What is this asking? For 4b, you're saying as x approaches 3 from the left, the negative sign there has nothing to do with a negative number being smaller than 0. Rather, it's a directional type of a situation. What they're really saying is, as x gets close to 3 from the left, what does the y value get close to? Now, I'm going to do something even a little bit bold here. I'm going to cross out what's happening at x equals 3. Before, you might have seen that there was a hole, there were open circles and closed circles. I'm crossing all that out so you can't see it. Now, of course, on your page you still can. And sometimes kids will, understandably ask, why on earth are you doing that? It's like you're covering it up deliberately, because a limit says as x gets close to 3 from the left, never equaling 3. That's where kids get into trouble. We're only getting close to 3 from the left. We're interested in what y is getting close to. I don't care what is occurring when x equals 3 when we have a limit. I'm just interested in what is happening as we're getting close. So in other words, you could say as x gets close to 3 from the left, what kind of numbers might we be talking about? How could x be close to 3 but be to the left of 3? X might be something like what? 2.9 maybe? Or 2.999? What's happening as I get close to 2.999? Tell me about the y value that I'm getting close to. 4. I don't care if there's an open circle over by 4 or a closed circle. I don't care whatsoever. I'm just getting close to 4. And that's why I deliberately erased temporarily what's happening with open circles and closed circles. It frankly doesn't matter. Look, we follow up for letter C. They're saying, well, what about 3 with a plus? This is 3 from the right. It has nothing to do with a positive number. It's directional. You're saying, look, I want to get close to 3, but from the right direction. In other words, if I'm just to the right of 3 on a number line, won't I be at something like 3.1 or something like that? So again, you could say, well, if I'm at 3.1, look where I'm going. I'm going about right here. What y value am I getting close to? 2. Do you see that? Now look, of course I could erase all this, and sometimes kids will say, oh, but look, there's an open circle over at 2, and there's an open circle up here at 4, and there's a solid point right here. Yeah, we don't care about all that because we're just getting close to 3 from the right side or from the left side. Is this making sense so far, I hope? The follow-up question is part D. Sometimes kids will say, no, wait a minute. You talked about the negative sign means we're going from the left. The positive sign means we're going from the right. What if there isn't a plus or a minus there? That means that you're really going from both directions, from the left side and the right side. Now, here's the problem. Do you see how we get different answers when we approach from the left and from the right? When that happens, we write D and E. The limit as x approaches 3 does not exist, because from the left side we approach 4, and from the right side we approach 2. Very important, and I'll write this over here. For the limit as x approaches 3 of f of x to exist, the limit as x approaches 3 from the right side must equal the limit as x approaches 3 from the left. That's the only way you can come up with a limit existing if you're not designating a direction. With no plus or minus, you're implying that you could approach from the right or from the left. And to get a valid answer, the left approach and the right approach must equal the same value. Okay? So, look, we've been talking a lot about x approaching 3. Letter E is not a limit whatsoever. Here's a 3. What do you think f of 3 would equal? 3. It's wherever you have a closed circle. It's wherever you have your defined function value. Okay? So that's just to get you started. Let's take a look at part A now. Ironically, we're jumping around a little bit. X approaches 0, meaning we're getting close to 0. So very often kids will say, now wait just a minute. You don't have anything designated in terms of direction. No, we don't. On the other side of the coin, though, it doesn't look like there's any controversy about y values around x equals 0. Whether I go to the right or whether I go to the left, it looks like I'm going to get very close to what y value? 3. And I can write a 3 this time because I have just checked that from the right side and from the left side, I'm in agreement. Okay? Tell you what, let's do some more. And tell you what, we'll scroll down a little bit. Because number 5 is just below it. And here's number 5. It says, use the given graph of f to state the value of each quantity. Look, you guys can't do this easily on your own paper, but at x equals 1, how about I blacken everything out so you can't even tell where there's a hole, where there's an open circle, where there's a closed circle, because frankly, with limits, it doesn't matter. I don't want kids to get confused with that. You black it out and you'd say, look, I'm just getting close to 1. Letter A, I'm going to get close to 1 from what side, the left side or the right? It's a negative, so we're going to be from the left. Like maybe you're saying, what happens when x equals 0.9? What y value are you getting close to? A 2. By the way, some kids really like to use 2 fingers. You can see I'm up on the board right here. You could say, well, when x is about 0.9, where's my y value? Oh, it's right here. Look at that. It's getting close to 2. So that, two-handed approach can help you out. Sometimes kids are like, cool, now the other one, the one from the right side is going to be 2. Ooh, be careful. Like at 1.1, you can see I moved my finger just to the right of that blue bar. Raise it up. Where am I touching my curve? I'm getting very close to 3. You see that? Notice I'm not even worried about whether there's an open circle or a closed circle. We could erase it. We could, clean that all up. Sometimes kids are like, does it even change anything if there's a open circle or a closed circle, if they're both open circles. Guys, it doesn't. Because I'm not interested at x equals 3 just getting close to it. Okay? What about x approaching 1 with no direction? Will it exist? No. Why? From the left side and the right side, we have disagreement. If you don't have the same value, you say DNE does not exist. Okay? And you look down here, x approaches 5. Well, wonderful question. Do you know what? Yeah, there's a hole here. But even more to the point, you know what, guys? You could black it all out. And, imagine somebody saying, I want to know if there's a hole there. It doesn't matter. It really doesn't matter at all. You don't care what's happening at x equals 5. You just want to be close to it. Okay, so look, if I go just to the right of 5, or if I go just a tiny bit to the left of 5, what y values do you think I'm getting close to? 4. Now, if I erase this right here, does the fact that there's a hole there make me want to change my answer? No. Sometimes that really bugs kids. They'll say, but wait a minute, Mr. Dobner, this is bugging me a lot. What that hole says is, you don't exist at x equals 5. I agree. That's part E. F of 5, you could say, what value is it? You can say it's undefined. You could also say DNE if you'd like. You could say doesn't exist. That's the hole coming in, because now it's not a limit. You're saying when x equals 5, hey, we're at this hole right here. You don't really get that y value of 4. You don't have any y value assigned at all. Is this making sense, I hope? Let's keep talking. Let's see if we can do another one. Forgive me, I've made this screen so big that it's got a mind of its own right now. Okay, so let's take a look at 6 real quickly. You can say, wow, look at this, another problem, amazingly close. Sometimes kids will say, what about -3? I'm going to be approaching -3. Hey, if you want to, you don't have to do this. I think you're going to not have to do this after a while, but you're going to say, hey, there's -3. What's happening when I'm going just to the left of it? What y value am I getting close to? 1, 2, 3. Up here's 4, isn't it? How about to the right of -3? What y value am I getting close to? 4. So what about the limit as x approaches -3? We'd say 4. Now, h of -3, kids will say, put down a 4. Be careful. We've got to peel away that bar. Because now we're not just saying get close to x equals -3. We're saying really let x equal -3. Big difference now. What is it? It doesn't. You want to say DNE, be my guess. Or if you want to write undefined, same idea, right? You're saying your function doesn't even have a y value. There's no point to talk about there. The limit can exist where the function does not. Okay? You look over at 0 and you can say, well, wow, at 0, my gosh, you know what? We can do the same game. We can say cover up what's happening at 0. People won't even be able to know where there's a hole, where there's a solid dot, because quite honestly, it doesn't matter for a limit. You can say, hey, look, at 0, you're approaching 0 from the left side. That's what that negative is. What y value am I getting close to? A 1. You can do that two-handed approach. You could say, well, as x is just a tiny bit over here, what y value are you at? Oh, right here at 1. Okay, what about as you approach 0 from the right? Where are you going now? -1. Do you see that? Look, you go just a little bit to the right. Where's your y value? Right below it. Right here by -1. What about x approaching 0 itself? What do you think? DNE doesn't exist at all. H of 0. I kind of need to see what's happening. What is h of 0? It exists, by the way. Here's the solid dot. 1. You see that? h of 0, there is a defined point when x equals 0. Your y